Hey everyone, this is a pretty big section in 7.2, so just make sure you're ready to take good notes. It's all about adding, subtracting, and multiplying polynomials. But before we can talk about how we add and subtract and multiply, we need to know what is a polynomial. So here I just want to write a simple definition for a polynomial. I'm going to kind of explain it for you. Basically, a polynomial is a monomial or a sum of monomials. Okay, so a sum of monomials. Well, you may not know what a monomial is. So a monomial is just something simple like x or 5x squared, something that's one term. So for example, 2x squared, okay? Or maybe 5 is a monomial, or 7. So a polynomial might look something like this. X squared plus 2x plus 3. Okay, this would be an example of a polynomial because we're adding a bunch of monomials together. And it can have some subtraction in there too. It could also be like 4y to the third minus 5 or 4x squared plus 3. Okay, now this is not y squared. Not the greatest example, but it's also a monomial as well. Now what's really important in a monomial is that you can identify two specific things. The first one is the leading coefficient. And when we talk about leading coefficient, leading means it's out in front. But in order for it to be the leading coefficient, you have to make sure that your polynomial is written from the highest exponent down to the smallest exponent. So when I talk about the exponents, if you notice here in my red one that's circled, the 2 is the highest exponent. This was an exponent of 1, and then technically this has an exponent, no exponent for x, it's just a 0. So that goes from highest to lowest, okay? And so then we're going to look at that, so let me just come up with an example. Maybe I have 5x to the fourth plus 3x squared plus 2. Okay, so this would be an example of a polynomial. My exponents go from the highest down to the smallest, which is good. So what's my leading coefficient? Well, my leading coefficient is the number that's out in front of my highest exponent. So that would be the 5 right there. All right, and you don't, it is going to be very helpful in the future for this chapter that you always write it in the order that is highest to lowest, even if it isn't to start, because later that's going to be useful when we get into synthetic division and long division. All right, and then the degree is whatever the highest exponent is. So leading coefficient and degree go together. Okay, so degree is the highest exponent, and that in this case would be the 4. Alright, so the degree is 4 and the leading coefficient is 5. And I put this little table off to the side here because these are going to be some important words that you're going to see quite a bit in this chapter. Basically, it's the names for the polynomials based on the degree. So if you have a degree of 0, that would look something like the number 4. Okay, the degree is 0, so the constant, it's going to be just a constant, just a number. Okay, if your degree, the highest degree is 1, it's going to be a linear function. So that would be like 4x plus 2. Okay, so the highest degree is 1, so it's linear. Okay, and you're going to want to know these names. The second one is quadratic, which we spent a lot of time in second semester, or first semester, sorry. That would be like your parabolas. Okay, so that U shape, and that would be something like 2x squared plus 4x minus 1. Cubic has a degree of 3, so maybe x cubed minus 2x plus 1. Okay, highest degree is 3. And then quartic is 4. So that might be like 2x to the fifth minus 4. All right, so highest degree is 5. So make sure you write down those names because you're going to need them later. And it's going to help you recognize what types of polynomials we're dealing with. Now from here, we're going to identify if something is a polynomial or not, just based on looking at the equation. So let's look at example 1. We have f of x. Remember, that's just the same thing as y. So f of x is equal to 6x to the 1/2 minus 5x. Well, did we have a degree in this table that was a fraction? No, we didn't. Okay, so in this example, this is not a polynomial because the degree, you have a degree in there that is a fraction. Okay, you cannot have a fraction in your exponents or any decimals or anything like that. Cannot have fractions, and you can also not have variables. Okay, so no variables is also useful. No fractions, no square roots. Okay, anything in the exponent other than a whole number won't work. All right, I'll write that in for the exponents. There we go. Now let's look at example 2. Example 2 has a decimal but not in the exponent, so that's okay. And our highest degree is a 3. So this one is a polynomial, so we could say yes. And the degree is 3. And the leading coefficient, which I always label LC, that's going to be 1, because that's the number out in front of the highest degree. And what's the name of this? Well, what is the name of a polynomial with degree 3? It's a cubic function. So those 3 things right there are going to be very useful. You're going to need to know the degree, leading coefficient, and what the name is, and if it is or isn't a polynomial based on your exponents. And then it'll also potentially ask you if it's in standard form. Standard form just means does it go from highest exponent down to lowest or not. And if it doesn't, then you need to write it in standard form. Now the rest of this should be relatively simple to do. We're going to talk about 2 ways to substitute numbers in. So the first one is going to be what's called direct substitution. So let me write here an example. If I ask you to use direct substitution for an equation that looks like this, y equals negative 3x cubed plus 2x squared minus 10, and I want you to substitute in when x equals 2. So all you'd have to do here when it says direct substitution is basically wherever you see an x, plug in a 2. You guys can do this. So we would have y equals negative 3, and then we'd plug in a 2 cubed, whoops, and then plus 2 times 2 squared, and then minus 10. So all I did was just simplify. So 2 cubed, that's the same as 2 times 2 times 2, which gets you 8. So we have y equals negative 3 times 8, and then plus 2 times 2 squared is 4, and then minus 10. And then we can simplify. So that's negative 24 plus 8 minus 10. So that gets us y is equal to negative 24, and then 8 minus 10, that's negative 2. So this is going to get us negative 26. All right, so there's our final answer. Now, synthetic substitution, which is in this next example, is the same concept, but rather than having to deal with a whole bunch of exponents and things there, what we're going to do is what will lead us eventually into our synthetic division. And this is going to be very useful that you get this idea down now, so when we do that later, you'll catch on really quick. So let's say I have this same equation. Actually, we'll do a different equation. Let's try. Okay, if I have the equation y equals 2x to the 4th minus 5x cubed minus 4x plus 8. All right, so here's my equation, and I want to use synthetic division. Now, this is going to be new. So the first thing that you're going to do, and I want to evaluate when x is equal to 3. All right, the first thing you want to do is basically write all the coefficients. So I'm going to make a box. This is where it's going to be kind of new. And I'm going to write every single coefficient of the numbers up here at the top. Now you need to make sure that you have all the exponents covered. So here the highest was x to the 4th, so we're going to write a 2. X to the 3rd was our negative 5. Do we have an x squared? No, so we're just going to write a 0. Then the next one would be the x, which is negative 4, and then lastly our constant, which is 8. So if you have something missing, you need to make sure you put a 0 in its place. And then the last thing we're going to do is we're going to deal with the x equals 3. Well, that's what we're plugging in, so we're going to write the 3 out on the left, outside the box. And now this process is all about just multiplying and adding, multiplying and adding. So what we're going to do is first bring down the first number, right? And then we're going to start multiplying. Well, what's 3 times 2? Well, 3 times 2 gets us 6. And then we write that under the next number, and then we go ahead and we add. So what's negative 5 plus 6? Well, that gets us positive 1. All right? And now what's 3 times 1? That gets you 3. And then we can add them together. So 0 plus 3 is 3. And then we do it again. 3 times 3 is 9. So it's just multiplying. What's negative 4 plus 9? That gets us positive 5. And then 3 times 5 gets us 15. Well, what is 8 plus 15? That gets us 23. So the last number that you get is going to be your final answer. So basically what synthetic substitution does is it gets rid of all the exponents. All right. So now what this means is if we were to plug x into 3 like we did in example 3, then we would get 23. Okay, so our final answer, we could say that x equals 3, which means y has to be equal to 23. And there's your final answer. So if you have any questions on synthetic substitution or direct substitution, let me know. But now we're going to get into adding, subtracting, and multiplying. So adding and subtracting should be super easy because it's just combining like terms. Basically, you just have to pay attention to your signs and make sure you combine like terms correctly. In this case, for example 5, I have t squared minus 6t plus 2. That's the first polynomial, plus 5t squared minus t minus 8. And all I'm going to do is combine like terms. So I have a t squared and a 5t squared. Those are my like terms. Well, when I add those together, I get 6t squared. Then I have negative 6t and negative 1t. Well, negative 6 plus negative 1 gets you negative 7t. And then last but not least, we have the 2 and the negative 8 because those are constants. So 2 plus negative 8 gets you negative 6. So there I added, and I'm done. Same thing for subtraction, except when you subtract, always distribute the negative first. That's important. Okay, and I'm going to write that down. Distribute the negative. So when I do that, I distribute the negative to all of these, and basically what this does is it turns it into addition. So we'd have 8d minus 3 plus 9d cubed, and then this minus sign becomes a plus, and now we have a negative d cubed. We have a positive 13d squared, because I distributed a negative and a negative, and then lastly negative times negative gets us positive 4. So now we have all like terms, and now we're just gonna, or all distributed, and we're gonna combine like terms. So here we have an 8d. Do we have any other d's? Nope, so we're gonna leave that as 8d. We have a negative 3 and a positive 4. That gets us positive 1. Okay. And then we have a 9d cubed and a negative d cubed. So what's 9 plus negative 1? Gets us positive 8d cubed. So 8d cubed. And then we have a 13d squared, which doesn't have anything to combine with it, so plus 13d squared. So there would be my final answer. And notice I did write everything from highest exponent down to the lowest exponent. That's a really good habit to get into starting this section. All right. If you have any questions about distributing, adding, or subtracting, pause and come ask. Otherwise, we're going to move on to multiplying. Multiplying, the most basic way to multiply is going to be your FOIL, but obviously we're going to start dealing with things that are a little bit bigger than simple FOIL. First, outside, inside, last. You're going to have longer polynomials, higher exponents. So we're just going to go through a quick example, and then I'm going to show you some basic shortcuts. So here, for example 7, we have 3x squared plus 3x plus 5 times 2x plus 3. So in basic FOIL, we do first, outside, inside, last, but there's more terms than there are in FOIL. So it's going to be kind of like the distributive property. So what I'm going to do is take my first term and I'm going to multiply it by the first one and the second. So 3x squared times 2x. Well, 3x squared times 2x gets us 6x cubed, because when I multiply the same bases, I add the exponents. Okay? And then I'm going to take that first term and multiply it by the second in the parentheses. So 3x squared times 3 gets us positive 9x squared. So I took 3 times 3 to get the 9, and there's no x's, so the x squared stays the same. And then I'm going to continue on with the next one in the middle, or in the first parentheses. 3x times the first, that gets me 3 times 2 is 6, and x times x is x squared. And then 3x times 3. 3 times 3 is 9, and there's only one x. And then finally, the last one, 5 times 2x gets us 10x. And then 5 times 3 gets us positive 15. And now I've multiplied everything out, I just need to combine like terms. So we have no other x cubes, so 6x cubed is going to stay the same. We have a 9x squared and a 6x squared. So those are going to combine to get us 15x squared. Now notice when I add, I cannot change exponents. Okay, that's only when you multiply. That's also a common mistake. Then I've got 9x and 10x, and I combine those, I get 19x. And then my constant is all on its own, plus 15. So here's my final answer. So now if I asked you, I could say, what would be the degree of this problem? Well, my degree would be 3. My leading coefficient would be 6 because that's the highest with the highest exponent. And what's the name? Well, it's a cubic function because it's a degree of 3. Right. Now the last thing I want to show you, I would definitely write these rules down. This is going to save you a lot of time when we get into more complicated problems. This is the special properties with multiplying. So pause the video if you need, copy down this table. Basically it's shortcuts rather than having to FOIL or write a bunch of things out and then FOIL. If you have something where it's a sum and a difference, so like this example here, notice it's the same exact thing in both parentheses, just different signs. If that's the case, the trick is that you square the first thing and square the last thing, and then you have a subtraction sign. And I wrote an example of what that would look like here. So x plus 4, x minus 4, that just becomes x squared, and then negative 16. All right, the middle term cancels out. Next is a square of a binomial. This is if you have a plus b all squared or a minus b all squared. Notice the pattern. The first thing is squared and the last thing is squared, and then the only thing that changes between the two is the middle term. What you do is multiply the a and b together, and then multiply it by the exponent. So a times b times 2, and that's what goes in the middle. And a times b times 2 goes in the middle, but with a negative sign. So I showed examples of those here. And then the last one is the cube of a binomial, which is a little bit more complicated. I just want you to see the pattern. You still cube the first and last things together, so a cubed and b cubed. And then in the middle here, we square, it kind of goes down a degree. So instead of a cubed, I now have a squared with a b, and then the exponent becomes the number out in front. Okay, and then I have the 3ab squared, so my exponent has just gone down 1 and b increased by 1. All right, so this pattern here is what you want to follow. If it's a minus sign, the only thing that changes here is the negative here and the negative here. All right, and like I said, I wrote down examples of where I get these types of properties here. So if you want to write those examples and then refer to them in the next examples. And these are going to be our last two examples to go through together. Make sure you ask if you get stuck. The first one is 5y minus 3 times 5y plus 3. Notice these are identical things but different signs. So if you go back to our properties, that's a sum and difference property. So what's the rule say? Well, the rule says that if they're the same but different signs, then I'd have a squared minus b squared for my final answer. So what is the a in this case? Well, the a is my 5y and the b is my 3. So I would have for this final problem 5y squared and then minus b squared. Well, now I can just simplify that. 5y squared gets us 25y squared because I have to square both the 5 and the y. And then lastly, 3 squared is 9. So there's our final answer. That saves you a lot of time versus trying to FOIL it all out, combining like terms, and hopefully it will save you from making some small mistakes. And then the last one is example 9, which is a cubic one. I wanted to go through this real quick with you. Remember, we've got something, this is our a value, this is our b value, and then it's all cubed. So if you go back to your example here, in our cube of a binomial, okay, we'd have a cubed minus 3a squared b, plus, then plus 3ab squared, and then plus b cubed. So I'm just going to start filling in what I know. Well, what's a cubed? Well, that's the 4a, because that's my a value. So 4a cubed, then plus 3 times a squared, so that's 4a squared, times b. Well, b is 7. Then I have plus 3 times my a value, that's 4a, and then b squared, so that's 7 squared, and then plus my b value cubed, which is 7 cubed. So it looks complicated at first, but now it's just a matter of simplifying, and this is where your exponent rules are going to come in handy. So in this case, we could do 4 cubed, so 4 times 4 times 4, that gets you 16 times 4, which is 64. So 64a cubed. Here we're going to do some little simplifying. 4 squared, that gets you 16a squared. And then 3 times 16 times 7, so 3 times 16 times 7, that gets you 336a squared. And then we do the same thing over here. We have 3 times 4a, that gets you 12a, and then 7 squared is 49. So what is 49 times 12? 588. So 588, and we just have an a left. And then lastly, 7 cubed gets us 7 times 7, that's 49. Then times 7 again is 343. So there is our final polynomial. So not pretty, okay, but this is going to save you a lot of time if you're trying to FOIL everything out rather than writing 3 terms and then multiplying. All right, so if you have any questions about cubes, squares, FOILing, distributing, please pause, let me know. I can give you some extra practice problems. Otherwise, you guys are good to go.